Welcome children. Today we continue with chapter 4 of Geography Climate for standard 9th, and this is the third part of the lesson. The Indian monsoon. Now monsoon refers to the seasonal reversal in the wind direction during a year, or we can say that monsoon is a seasonal change in the pattern of wind flow or the pattern of rainfall. In India we commonly associate monsoon to rainy season, and the phenomena of monsoon was first noticed by the Arab traders who had come to India for trade purposes during the medieval period, and the monsoons helped them navigate to India. In their journey they had commenced at the mercy of the winds, and so when the Arabs named this seasonal reversal of wind system as monsoon, and actually it comes from an Arabic word mosam, which means season. Now today we learn about the mechanism of monsoon, and under these there are differential heating and cooling of land and water. Then we look at the shift of position of ITCZ and the presence of high pressure area east of Madagascar, then the heating of the Tibetan plateau and the movement of jet streams. Children, now let's look into the first mechanism, the differential heating and cooling of land and water. Now all of you know that land becomes cold and hot very quickly, whereas the ocean takes a longer time to get hot and cold, takes a longer time. Now let's see how this affects the climate of India. Now children, due to the differential heating and cooling of land and water, what happens to India is it creates a low pressure on the land of India, land mass of India, and the seas around it experience high pressure. And so all of you know winds blow from high pressure to low pressure, and that's the reason why these winds get into India and pick up moisture from the ocean and bring rainfall to our country, India. The next mechanism is the shift of the position of ITCZ. Now what is ITCZ? Intertropical Convergence Zone. Now children, all of you know that the earth goes around the sun, yes, and the direct rays of the sun falls on the equator, and this region becomes very hot. Okay, 10 degrees north and south of the equator is very hot, and here it becomes hot, the air here becomes hot and warm air rises, creating a region of low pressure. So winds from high pressure belts starts to come towards the low pressure belts. Now which winds come? Northeasterlies and southeasterlies. They come and meet at the equator, converge, forming an intertropical convergence zone, and this zone keeps shifting. Okay, so you see children, when the sun shines on Tropic of Cancer, this zone, ITC zone, also shifts to Tropic of Cancer, and the same happens when the sun shines at Tropic of Capricorn. Then the ITC zone will shift to Tropic of Capricorn. So you see now children, the sun rays have shifted to Tropic of Capricorn, and the ITC zone also has shifted to Tropic of Capricorn. Now when the ITC zone is in the Tropic of Cancer, now this helps to create low pressure and attracts the southwest monsoon winds, and which bring rainfall to India. Children, the next mechanism is the presence of high pressure area east of Madagascar. Now children, you can see in Africa there's a small island called Madagascar, or approximately 20 degrees south over the Indian Ocean. This here there is a development of high pressure, and since there is high pressure and there is low pressure in India, it intensifies the winds to come into India. It helps in bringing the southwest monsoon winds towards India. Okay, so this is one of the reasons for bringing rain to India. The next mechanism is the heating of the Tibetan plateau. Now during summers, this Tibetan plateau gets intensely heated, and which results in creating low pressure area. Okay, because of the shifting of ITCZ, this area becomes very, very hot, creating an area of low pressure. So when low pressure is created, what happens? Winds from high pressure will go over this region and bring rainfall. So you see, children, the Tibetan plateau is heated. It creates a region of low pressure, and this helps to attract the southwesterly winds and bring it to India. So this is another mechanism which brings rain to India. Now the next mechanism is the movement of jet stream. With the shifting of the ITCZ, the jet streams also move. In winter, the jet stream is towards the south of the Himalayas, okay, and in summers this shifts to the north of the Himalayas. So you see, children, this jet stream which was towards the south of the Himalayas now shifts towards the north of the Himalayas during summers, and this also helps in attracting the rain bearing winds to India. Another factor that affects the climate of India is ENSO. Now ENSO, it is a short form for EN is for El Nino and SO is for Southern Oscillation. Okay. Now what is oscillation? You can understand this through this diagram. You can see this ball is now dwindling this side, and then again it comes to the other side. So what oscillates? The oscillation between warm ocean current and cold ocean current. Sometimes the warm current comes here and the cold ocean current is there, or vice versa. They keep shifting. So this is like an oscillation. Okay. So that is what we are going to learn, how the warm current and the cold current keep shifting and oscillating. Now children, look at this map. You can see here is the Pacific Ocean. Yes, this is the tropical eastern South Pacific Ocean. Here there is high pressure. This is in a normal situation where normally there is high pressure, and towards the eastern Indian Ocean we have low pressure, and normally winds always blow from high pressure to low pressure. This is a normal situation, but at times what happens? Now in certain years, whenever the trade winds are weak, there is a reversal in the pressure comparison. Now what happens here? There become high pressure develops in the Indian Ocean and low pressure in the Pacific Ocean. So now winds will blow in the reverse direction. It will blow from high pressure, that is from Indian Ocean, towards Pacific Ocean. And when this reversal takes place, so we see when this happens, when there is a shift between the high pressure and low pressure, it is called as Southern Oscillation. The periodic change in the pressure condition is called as Southern Oscillation. So whenever it's in a normal condition, when there is high pressure in the Pacific Ocean and low pressure in the Indian Ocean, winds will blow from high pressure to low pressure, and at that time we'll have strong monsoons. And whenever there is a shift, when there's high pressure in Indian Ocean and low pressure in Pacific Ocean, what will happen? Winds again will blow from Indian Ocean towards Pacific Ocean, from high pressure to low pressure, and that we'll have weak monsoons. Children, let us understand another phenomena that affects the Indian monsoons is El Nino. Okay, now all of you know that weather depends a lot on the ocean temperature. When the ocean is warm, more clouds are formed and more rainfall it gives to different parts of the world. Okay, now let us look at this ocean, the Pacific Ocean. Near the equator, the sun makes the water warm on the surface, and in normal condition, that what happens is when strong trade winds along the equator, they push this warm surface near the South American coast. You can see this is the Peruvian coast. It pushes it towards the westwards towards Indonesia. Now when this happens, what happens? In the cool water from underneath rises towards the surface of the ocean near South America. Okay, now In some years, these trade winds become much weak. Then what happens? Let us see in the next slide. Now, in some years, these trade winds become weak, which blow over the Pacific Ocean near the equator. They become weak. So what happens? Then they blow the other way around. Okay, so now they blow towards South America instead of Indonesia in October. So the warm surface water along the equator piles along the coast of South America. Okay, and what happens here, this region has warm current, this gets more rainfall, this area of South America gets more rainfall, and many fishes that were there in the cooler waters of the coast of South America move away or die. And that is why the fishermen here call this condition of the warm coastal waters as El Niño, which means Christ child, because this current comes during the month of Christmas. And so there's a reversal, and this happens almost every 4 years. Okay, and when this El Nino is there, then we have weaker monsoons in India. Now the pressure difference over Tahiti, which is in Pacific Ocean, and Darwin, which is in northern Australia. You can see Tahiti here in the Pacific Ocean and Darwin in northern Australia, is computed and to predict the intensity of the monsoons. If the pressure difference were negative, it would mean average and late monsoons. Okay. Children, with this we come to an end to the third part of this chapter. Very soon I'll be coming up with the fourth part of this chapter on climate. Till then, do view and subscribe. Thank you.